So, good evening, good afternoon, everybody. Today, I would like to tell you my PhD project and the results obtained during this first year. The PhD project is part of carbon capture and underground storage, a topic which is progressively becoming more relevant in addressing the environmental needs derived by global warming and climate change. In particular, the research is devoted to investigate the impact of CO2 injected underground in different reservoir rocks in order to evaluate their potentiality to act as natural catalyst for the CO2 conversion in new green useful fuels, like could be the methanol. This is at the base of a project named GeoFac, which means Geological Factory, which is a multidisciplinary project in collaboration between the University of Perugia, the NEA Institute, and Queen's University of Belfast. In particular, in this project, my contribution will be to understand the behavior, the interaction of carbon dioxide injected and the hosting rocks from a petrophysical, mineralogical, and geochemical point of view. Regarding the petrophysical characteristics to describe, I'm mainly focusing on the mineralogic textures, the type of porosity, both primary and secondary, and the types of cement present. In the meantime, I also trying to quantify each features with the help of image analysis software. Moreover, mineralogical and geochemical characterization resulted necessary in order to predict the behavior of the main protagonist involved in a reservoir system, like can be different minerals, the interstitial fluids, the carbon dioxide itself, and also the measure and trace elements which can be involved in different geochemical reaction, where they can act as natural catalyst for the CO2 conversion. At the beginning of the years, I decided to sample and study different sedimentary body with different lithology and from different geological context. In particular, I collected rock sample here in the central Apennine of Italy because they could be because they can be considered very good reservoir rocks for their similarity with other analogs lithology present in the rest of the world. And as first case of study, I collected different type of carbonate rocks, either dolomites and not, and regarding carbonate rocks not affected by dolomitization process, I collected two types coming from the Umbria-Marche lithostratigraphic succession. One developed mainly from shallow water carbonate platform, which is represented by calcare massiccio, and the second one developed mainly from deep water and pelagic depositional environment, which is represented by Maiolica formation. For the dolostone samples, I collected dolostone sample from Castelmanfrino dolostone, which is a completely dolomitized unit cropping out in the Montagna dei Fiori Anticline on the southeastern side of the central Apennine. And moreover, as a second case of study, I selected also terrigenous and siliciclastic rocks, in particular sandstone coming from flysch deposits, and also I collected mixed siliciclastic carbonate rocks. They are very interesting for their heterogeneity in terms of mineral composition, and presenting both carbonate minerals and siliciclastic minerals, which can interact in different way with different CO2 saturated brine condition. From preliminary results have been obtained from petrographic analysis of carbonate rocks. In particular, limestone presented are characterized mainly by primary porosity due to grain-supported textures, and the micritic limestone resulted mainly characterized by much more controlled by a secondary type of porosity due to its the presence of well-developed system of fractures. Instead, for the dolostone sample, they resulted particularly interested by intercrystalline porosity due to its, in particular, where they are characterized by planary textures. After a first petrographic analysis, other techniques such as X-ray power diffraction and X-ray computed tomography have been considered in our study. All these methods and the data acquired can, as also highlighted during my master thesis work, can provide a predictive model for the petrophysical property distribution of reservoir rocks. This in order not only to distinguish between high and low quality reservoir rocks, but also in order to describe and quantify all the interface contacts which will go to interact with the CO2. And this will be possible. This is possible focusing on different parameters such as the mineralogic textures, the pore size distribution, and the connectivity of the intercrystalline porosity. Other preliminary results have been obtained from micro-Raman, other two techniques such as micro-Raman and ATR F-tile spectroscopy. Such techniques works on the mid-infrared range, where we can obtain information about the different molecular vibration patterns. So each one with a characteristic frequency about inorganic and organic compounds. These techniques are very much used at the moment in study for CCS project, because they are able to distinguish between carbon dioxide in different gaseous and solid phase, and also at different reservoir condition. Moreover, I initially focused on carbonate rocks because they, as we know, they are strongly influenced by the carbon dioxide, and because they are influenced by the presence of CO2, so leading to a disequilibrium of both fluid chemistry and pore pressure inside the reservoir system, which triggering to a series of geochemical reaction which can result in a new mineral assemblage and the petrophysical arrangement. So at the moment, spectral analysis and interpretation were done using Origin and Opus data analysis software, and the results obtained were devoted to describe in a qualitatively way the molecular bound vibration for typical carbonate minerals in order to distinguish the main mineralogic phase inside. As expected, two carbonate phase were identified on the basis of the main peaks present in the infrared absorption spectra. In particular, we observed a shift in both Raman and in both Raman and F-tile spectrum due to the carbonate phase transition and resulting from low magnesium calcite, in particular, which characterizing limestone sample, and high magnesium calcite, which characterizing dolostone sample. As a future perspective, at the beginning of the next year, I'm planning to go at the AI Institute at Rome in order to complete the acquisition of both Raman and F-tile spectrum for the remaining lithologies. But in particular, I will go to perform new analysis. For example, I will use the scanning electron microscope equipped with an ADX assemblage in order to investigate more in detail the chemical composition of specific grain and or minerals and or cement. And in the meantime, I'm keeping contact with Queen's University of Belfast, where we send different lithology, different lithology rock sample to analyze in order to compare our data in future. At the end, I hope also to perform a 3D microtomography analysis before and after core flooding experiments conduits under reservoir temperature and pressure condition. This is in order to showing evidence of petrophysical and geochemical variation due to the CO2 rock interaction. Here we can see all my education activities during this year, and thank you for your attention.